Hi, welcome to lesson 22E, compound events. The goal of today's lesson is to learn how to calculate probabilities involving compound events. Now, compound events are where two different activities are occurring at the same time. So, for example, rolling a die and tossing a coin at the same time. There are other options, other possibilities of compound events, which we'll see as we go through some examples and exercises. Tomorrow we're going to be looking at an investigation that looks at different probabilities when we roll a die and toss a coin. So that'll be something that we'll look at in class. Before we get to that, what we're going to do is we're going to look at a couple different things called independent events and dependent events. So when an event is an activity that we do, some sort of an experiment, so that we can see what kind of compound event, or the two events, or whatever, or three events of a compound event are independent or dependent. So events are independent if the occurrence of either of them does not affect the probability that the other occurs. So, for example, when we look at the investigation tomorrow, we'll see that rolling a die and tossing a coin are independent and they don't influence one another. So we can roll a die and get a 4, and we can flip a coin and get a tail, and the fact that we got a 4 with the die does not affect the fact that we got a tail with the coin. So 4 on the die, tail on the coin. It doesn't affect each other. So those are called independent events. So when we have independent events, we can say the probability of event A, say rolling the die, and, which would be the intersection of, later on we'll find this out when we deal with Venn diagrams, the intersection of, and the event B, which is rolling a die, or sorry, tossing a coin. If we were to find the probabilities of each of those, and if it's independent, then the probability of event A occurring multiplied by the probability of event B occurring. If they're independent, then this is the way we could calculate them. Okay? And this concept can be extended. Suppose we had three things that we were doing. Suppose we were rolling a die, we were tossing a coin, and we were choosing a colored marble out of a bag or something. And you'll find that there will be lots of examples of pulling a marble out of a bag. So let's say we've got the probability of A, which is rolling the die, and the probability of B, tossing a coin, and the probability of C, choosing a blue marble out of a bag. That would we would be able to calculate that probability by multiplying each of the individual probabilities together, because each of the probabilities don't affect each other, so we can take each of those probabilities and multiply them together to get the final probability of A and B and C occurring at the same time. When we look at dependent events, events are dependent if one of the events affects the occurrence of the other event. So, for example, if we were to suppose we had, again, our bag of marbles. Suppose we had blue and green marbles in a bag, and suppose we had 3 blue marbles and 5 green marbles. The probability of pulling out a blue marble at the beginning in a blind, very random manner would be that the probability of blue would be, well, there's 3 marbles that are blue out of a bag of 8 marbles. Then if we've chosen that and we have not replaced that marble, then if there's a probability of a blue marble the second time, then because we've already chosen one marble, there's now only 2 blue marbles left, and there's still 5 green marbles, so the probability of choosing a blue marble the second time would be 2 out of 7. Or, conversely, if we chose the blue marble first, and then we wanted the probability of a green marble, we would say that there's 5 green marbles still, but now there's a total of 7 altogether because one of the blue marbles has been taken already, so there's only 2 blue marbles left, along with the 5 green marbles, so the probability of pulling out a green marble is 5 over 7. So this is an example of a dependent event. It's a compound event because there's 2 things happening, but it's dependent because the second probability depends upon what happened in the first. So we could write this as the probability of A then B is equal to the probability of A multiplied by the probability of B, given that A has occurred. Okay, so that's how we would calculate then the dependent events. So independent and dependent are different, but they're both compound events. So what we're going to do is, I would suggest now, before we look at our examples tomorrow, that you look at example 8 from page 582. Then you look at examples 1 to 6 from page 583. After that's been done, you can look at example 9 and 10 from page 584. And then just kind of briefly glance through equations or questions 1 to 5, page 585. Again, you're going to have time to work on these tomorrow after we look at some examples, after we answer some questions, and look at the investigation. So once again, thanks for watching, and we'll see you in class.